Hi friends, this is DEEPU from India. I'm a PG scholar in Power Systems Engineer. First of all, thank you for watching my video. So, why I'm standing in front of you is to give some explanation about electricity. After watching this whole video, you can able to explain the fundamentals of electricity. So, we all know electricity is an indispensable part of our life today. So, conservation of electricity is very must. The per capita income of a country is depend upon the production and conservation of electricity annually, right? So, the annual production of electricity is the key point for the development of a country. So, in this video, I like to give you the whole explanation of electricity, how it is developing. So, in our world, all the matters are composed of solid, liquid, and gaseous particles, right? So, the matters are divided into three types: solid, liquid, and gas. How we can tell it is a solid, it is a liquid, it is a gas, like that? Because inside the solid, all the particles are tightly bonded. Hence, there is no chance for the free electrons to move. It is tightly bonded. But if you are seeing in a liquid, it is partially bonded, and the electrons can move somewhere inside the container. But in a gas, it is tight, it is so loosely bonded, and these electrons inside that, the particles can move anywhere. So it is tight, we have to close the gas particles tightly, right? So, well, we will see how the matter is composed of energy. You all know the conservation of mass. That is, energy can neither be created nor be destroyed, but it can be changed from one form to another form. Like that, just we will take a matter. What is inside the matter? When we are taking a matter, it consists of a nucleus, right? So, a matter is made up of molecules. All the molecules are made up of tiny particles known as atoms. So, we know the solar eclipse, sun is the center and the planets are revolving like around it, right? Like that, inside the matter, there is a nucleus. In this nucleus, it consists of protons and neutrons, and outside the protons and neutrons, electrons are revolving round in the outer shell. Okay, so these protons and neutrons are having same mass, and electrons having very negligible mass than the protons and neutrons. Okay, protons are positive charged particles and electrons are negative charged particles. Inside the atoms, there are protons and neutrons having same mass or composed. Let us take a matter. This flow of electrons, how it is happened, the flow of electrons. We know electrons are flowing from negative side to positive side, right? So let us take a sheet of paper. It consists of protons and electrons. Protons are positive charged and electrons are negative charged. So inside the paper, the positive charged particles are equal to negative charged particles, hence there is no flow of positive particles and negative particles. So it is in equilibrium position. But if you are taking little bit positive particles, that means little bit protons outside, means what will happen? Will happen the increase of negative charge, and the electrons will be increased. So we can tell the particle is negative charged. Okay, because number of negative particles will be increased. Same to that, if we are taking outside some electrons, means it will result in the production of positive charge. Hence, the flow will be through negative side to positive side, but it is not in equilibrium position. So, this technique is used for the production of electricity. The Let us say, for example, we will take a battery. Inside the battery, it consists of anode, positive side, cathode, its negative side, and electrolyte. Okay, so this what will happen when it is connected by a wire? Anode and cathode is connected by wire. It will be flow of electrons from negative to positive side because it is not in equilibrium position. So it will be flow. The electrons will be flow till it will reach the equilibrium position. Then the battery will be dead. So what's the result? Battery will be dead because of the equilibrium position of neutrons and electrons, negative and positive side. Just this is the basic technique. We all know the father of electricity is Michael Faraday. What's the technique used by Michael Faraday is Faraday, sir, he is very thorough in the matter, the production of matter, the charge inside the matter, like that. So what he done, he took a magnet. He know very well this magnet consists of fluxes. Magnet has south pole and north pole. The fluxes will be produced inside outside. Fluxes will be produced outside the magnet. So this magnet, these fluxes will be will be the rounded position, right? When we are using a conductor for cutting these fluxes, what will happen? There is some production of charge inside, right? So two magnets are tightly placed in two positions. There will be flux produced between the magnets. So when we are cutting these magnets, the fluxes of magnets, by using a conductor, surely there will be a production of charges. Let us use the conductor to flow by using this fluxes of production of charges. We can produce electricity. This is the technique used by Faraday, electromagnetic induction. This principle is used in all the motors, generators, like that. Okay, the principle of electromagnetic induction. So let us see what is voltage, what is current, what is electric power, what is electrical energy, all these things. We are all confused. We all know voltage is measured by volts, current in amperes, resistance in ohms, conductance, electrical power in watts, like that, electrical energy in kilowatt hour, that is units. But how it is producing, it is a confusion, right? It is confused for all of us. Voltage. Voltage is nothing. It is sometimes tell us potential difference. So potential difference or volt, we can easily tell it is V is equal to W by Q. W is nothing, work done in joules, and Q is charge in coulombs. So if there is in a material, it is some work done, means the work done to produce 1 coulomb of charge is known as volt. Okay, we can tell this 1 volt means 1 joule is produced in for producing 1 coulombs. Okay, so don't forget V is equal to W by Q. W is equal to work done in joules, Q is equal to charge in coulombs. Okay, so what is electric current? Electric current means electric current, the unit says ampere, right? So nothing. There is some flow of free electrons, means just time taken for the flow of free electrons. It is known as current. Time taken for the flow of free electrons is known as electric current. Electric current I is equal to Q by T. Q, I already told you, Q is nothing, the charge in coulombs. The charge in coulombs by T times second. That is, we can tell 1 ampere of current is produced by the 1 ampere of current is equal to the 1 coulombs, that is charge in coulombs, 1 coulombs by the 1 second. Okay, so 1 coulomb produced in 1 second. The flow of 1 coulomb at 1 charge in 1 second is known as 1 ampere. Okay. Then we will see what is electrical power. Electrical power is nothing. It is measured by watts. Okay. P, right? P, electrical power we can explain by P. P in the measuring of P, the units is watts. So P, we all know P is equal to VI, like that. Okay. But P is nothing but the W by T. Work done by T is known as P. That means work done means voltage into current. Okay. So number of power produced by time T is known as electric power. Right. Then we will go through electrical energy. What is electrical energy? Electrical energy is measured by kilowatt hour or units. 1 kilowatt hour is the consumption of 1 kilowatt in a single hour. For example, you are using 1 kilowatt, is equal to 1000 watts, right? If you are using 1000 watts heater, electric heater, or a AC, like that. Okay, 1000 watts AC in 1 hour, it will produce 1 unit. Okay, so easily tell 1 kilowatt hour is equal to 1000 watts consumed in your home in 1 hour. We are using this techniques in incandescent lamps, CF lights, all these things, tube lights, anything. You can easily calculate the production of electrical power. Then we will go through resistivity and conductivity. What is resistance? Resistance means the flow of, that is opposing of the flow of electrons. We are taking a copper. It is allowing there is the number of free electrons, number of molecules, like that, right? So if it is that copper is resisting the electrical energy, means there is increasing of resistance, that is known as electric heater. So there are, some materials, it is it consists of number of molecules which are tightly bonded, like solid papers, glasses, like that, insulators, that is plastics. All these are known as non-conductors. And aluminum, iron, um, and copper, these are known as conductors. The difference is conductors consist of number of free electrons. So this electrical energy can flow through free electrons. So if it is opposing by copper, means we can produce heat. So heater consists of a resistance, powerful resistance, which is opposing the flow of electrons. That is, resistance is measured by ohms. Okay, so we can easily calculate resistance. That is why the formula, Kirchhoff's law, V is equal to I by R. You know the Ohm's law, right? In Ohm's law, it is easily explained. V is equal to I by R. So I is equal to V into R. That is simple formula in Ohm's law. And you have to thorough in Kirchhoff's voltage law, Kirchhoff's current law. Then you can understand easily the difference between voltage and current. Then we will go through conductance. What is conductance? The reciprocal of resistance is known as conductance. So don't forget, resistance is opposite of free electrons, that is flow of electrons, and conductance is allowing of free electrons. Then we'll go through the importance of electrical energy. Economics of electrical energy. Electrical energy, we all know, in the country, the development of country is already depending upon electrical energy. If it is the industry, home appliance, anything, we have to use electrical energy. Electrical energy is the key or basic part of a human being, standard of a human being. So conservation of electrical energy is very must for us. Let us see What is the how we can produce electricity? What is the character of electricity? That is the importance of electricity is flexibility. That is, it can be transformed from any state. That is heat. It can be converted into heat. It can convert into light. It can be converted into mechanical energy. All this chemical energy it can be converted into electrical energy. So flexibility, easy to usage, controllability, high transmission efficiency, all these techniques, all these are the speciality of electrical energy. Don't forget controllability, easy to maintain, easy to use, then high transmission efficiency, then all flexibility. All these techniques, all these are characters of electrical energy, right? So easily electrical energy can be transferred from one place to another. It can be changed from particular 100 volts to 1000 volt. It can be step up through transformer from 100 volt to 1000 volt, and can be step down using transformer 1000 volt to 500 volt. Like that, anything we can transfer, we can transmit electricity from very long distance. Long distance transmission is possible through electricity. So what is the theory behind electricity is we will consider a power plant. It consists of a prime mover. Prime mover may be steam turbine, wind turbine, water turbine, anything. This mechanical energy from kinetic energy from wind, then heat energy from steam, anything. It can be converted into mechanical energy by prime movers. That it will be a turbine. It will be produce mechanical energy, and this mechanical energy is converted into electrical energy by using some alternatives. So the arrangement consists of prime mover and an alternator. Alternator is the nothing AC generator which converts mechanical energy into electrical energy. Okay, then we'll go through the sources of generation. There are different sources of generation. We all know renewable energy like sun, wind, and thermal, like that. So the types of generation are conventional and non-conventional, non-renewable and renewable. Okay, non-conventional means renewable, conventional means non-renewable. So according to this renewable resource and non-renewable resources, it consists of sun, the sun, solar energy, wind energy, steam energy, that is fuel energy, nuclear energy. Okay, so there are some ocean energy. All these things are there. Just we'll see the important thing, that is sun. In solar energy, what is happen? The sunrise, the powerful heat sunrise are absorbed by using some reflectors, and these reflectors convert heat energy from sun into steam energy. This steam energy is converted into mechanical energy by using some turbines, that is prime movers, and this prime movers gives the mechanical energy into alternators. This alternates converts mechanical energy to electrical energy. This is the technique used in solar energy power plants, solar power plants. Then we will just go through wind power plants. Kinetic energy from wind, that is only possible. Wind energy, there are, you know, the places that used for wind power plants. It is must that their speed of wind must be in 17 kilometer per hour, that is 5 to 7 meter per second. If wind power, wind speed of wind increase means the production will be increased to 8 folds. The height of the, that is tower height, height of the wind turbine increase means we can we can increase the production to 4 folds. If you are increasing the blade size into double means we can increase the production into 2 folds. So don't forget the 8 folds, 4 folds, 3 folds, increasing the height of tower, and then increasing the size of blades, then when the increasing of speed of wind, all these things. Okay, then considering wind energy, wind power plant, the flow of wind produces kinetic energy. This kinetic energy is converted into mechanical energy by using wind turbines. This mechanical energy is again converted into electrical energy by using DFIG, that is doubly fed induction generator. This doubly fed induction generator converted this mechanical energy into electrical energy, and we all know wind and solar are very useful renewable energy resources, but it has more problems that variability and unpredictability. The sun energy is not present in rainy season and at the night like that, but if you are seeing wind, it is available on a whole day, but we can't predict the production cost and the production annual production rate of this wind energy and solar energy. Now all of us are more concentrated in renewable energy for reducing the production of carbon monoxide, right? So to avoid the global warming and conservation of nature, we have to use renewable energy. Also, we are digging the most heat part, that is we know the core of earth. Under the earth we are going some distance, means the temperature is equal to 5000 degrees celsius. This heat energy is converted to steam energy, and steam energy is again converted into mechanical energy, and mechanical energy to electric energy by using some steam power plants. And also this is a technique used in thermal power plant. In thermal power plant, the raw material is coal, and the steam producing from coal is used to rotate the prime mover, that is some turbines, and this turbine mechanical energy is converted into electrical energy by using some alternatives. So these are the techniques used for fuel power plants. And finally, the nuclear power plants. What is in nuclear power plants? We all know after the Second World War, it is founded that more heat is produced by using nuclear bombs. So, under these techniques, uranium is the basic part used for nuclear fission. There are two processes in nuclear power plants: nuclear power, that is fission and fusion. Here it's using fission process. Uranium is the basic part, and this uranium converts by using nuclear fission. More production of electricity is possible. So we have to concentrate in nuclear power plants, but it is more dangerous that the decomposition, that is disposal of radioactive materials, and the leakage of nuclear energy is more dangerous for all of us, right? So we have to be alert by using nuclear power plants. But the main usage of nuclear power plant is 1 kg of uranium, that is nuclear power, is equal to 1000 tons of coal. Don't forget, 1 kg of nuclear is equal to 1000 tons of coal. So we can produce enormous amount of energy through nuclear power plants. So when considering these power plants, is the most cheaper power plant that unit produced by power plants is thermal power plant. Thermal power plant can supply one unit at 10 paise like that. But considering hydro also, it is more cheap. It can supply the electrical energy as at 60 paise per unit. But when you are going to solar, it is more costly. Most costly power plant is solar, because it takes more initial deposit, and annual production is also more costly. It will take around 12 to 16, 12 to 14 rupees per unit for a single unit. When we are considering wind power plant, it will give 6 rupees, 6 or 7 rupees per unit. Okay, so what's the government done? Government is adding subsidies to reduce this high rates. It is you know, electrical energy agency, international electrical agency, want all the world that they have to use this much renewable energy. So we have to integrate renewable energy and non-renewable energy. So by integrating renewable and non-renewable energy, there will be fluctuation or volatility in the price, electrical price. So this volatility of electrical price can be controlled by adding subsidies by central governments. Okay. So for encouraging renewable energy resources, international electrical energy agents are supplying around 120 billion crores of money per year. So these are high amount. So we have to be concentrate in renewable energy resource. We have to encourage renewable energy resource to conserve our world. Finally, the efficiency. Efficiency is what is efficiency of a power plant. We know the input is entirely different from output. We are giving powerful input also means the input will be reduced due to some losses and the output will be less. So efficiency is given by a ratio of output by input. Output energy by input energy is known as efficiency. Okay, don't forget. So considering all these power plants, they are entirely different from initial cost, running cost, and fuel cost, all these things. But better we have to use hydro power plants, then wind power plants, solar power plant. Then we can reduce the emission of carbon monoxide, and we can conserve our earth into a global finest globe finest planet by conserving the renewable energy resources and avoid non-renewable energy resources. I think in India after 2050, we will use at least 75 percentage or 80 percentage only renewable energy resources. So all of us are concentrated in renewable energy resources. China proclaimed that they can supply to the whole world at a rate of thermal energy is equal to solar energy. So they will supply a rate of thermal energy so that they can reduce the rate enormously. So just concentrated in renewable energy resources, conserve our nation. Thank you for watching this video. If you like this video, please give like. If you don't like means give on like. But please encourage me if you want to know about electrical energy, and if you want to know all the parts in electrical energy, I will add more and more videos explaining every parts inside the electrical energy. This is a basics. I'll give this video as a basics of electrical energy only. So once again, thank you for watching my videos. This is DEEPU signing out from YouTube. Thank you.